Intrinsic special attributes. Do you remember a few slides ago in this course we were introduced to the string method, the method that had two underscores before and after its name? Well, now we shall speak more about these methods. These are referred to as special methods or intrinsic attributes. These special attributes, as may be inferred from the name, allow us to obtain extra and additional information about our class or object in Python. To experience working with these special attributes, we will apply these methods to our book class data type. Every class in Python and every object in Python has a set of these intrinsic attributes that are configured by Python during script runtime. A few common methods for classes and objects are as follows. I will also be running the code from the IPython console. It will save me from having to screenshot the print statements and output separately. A few of the special attributes for classes are: number 1, the name method will tell us the name of the class. Book.name, output book. Notice that we obtain output directly in the IPython console. As a reminder, you have the ability to print this information from your editor and then run the script to show output. Output will be the same. I am using the IPython console for this portion of the tutorial to save some time. We are able to see code and output in the same window. Number 2, the module method will tell us the module or library from which this class was loaded. Number 3, the bases method will show us a collection of the base classes belonging to the class that we are looking up. We will learn more about this later on in a topic called inheritance. Number 4, the dict method will provide us with a dictionary, a set of key value pairs containing all the attributes of the classes, including methods. Number 5, the doc method will allow us to obtain and view the docstring, documentation string. Two of the most common special methods that are used on objects are: number 1, the class method will tell us the name of the class to which the object belongs. For example, we can create a book object and then check the name of the class to which it belongs. Book is equals to book How to Train Your Dragon, Casida Cowell 256. Print book.class. Output will show as follows: class main.book. Number 2, the dict method will provide us with a dictionary containing all the object's attributes. Book.dict, title How to Train Your Dragon, author Cressida Cowell, pages 256. Class side behavior and data. Up to this point in our journey with classes in Python, we have looked at functions, methods, objects, and classes. What is interesting to note is that classes in Python have the ability to hold data and methods, behaviors that are not a part of an object instance, but are instead a part of the class itself. In simple terms, we have defined methods that are able to be used on objects and not on the class. Now, however, we will look at how to create methods that can be accessed by the class and not the objects. In Python, classes can also have attributes, methods. When there are variables that are for the class, these are called class variables, attributes, as compared to when these variables are inside methods which have been defined for objects. In this case, we know of them as instance methods, instance variables. This section or portion of the work basically involves logic. You see, in Python, when there are variables defined within the vicinity of the class, we call it the scope of the class. But outside any methods, these variables are tied or bound to the class itself instead of to the instances of the class. Therefore, we call them class variables. I will give you a simple example. Let us remodel our book class to make it a bit simpler. Class book. Create a book object in Python. Define init self parameter title, parameter author, parameter pages. Self.title is equal to parameter title. Self.author is equal to parameter author. Self.pages is equal to parameter pages. So, we have a simple book class data type that we have created in Python. Now, we would like to add some side data to this class. In our case, we could keep a track or record of how many book objects have been created from the book class. To do this, going by the information on the previous slide, we are required to create a variable that is within the scope indentation of the class but outside any methods. So we could essentially create the variable as follows. Let's assume that we will call it instance count. Class book, create a book object in Python. Instance count is equals to 0. Define init self parameter title, parameter author, parameter pages. Self.title is equal to parameter title. Self.author is equal to parameter author. Self.pages is equals to parameter pages. So that meets the first expectation. Our variable is within the class but outside any methods. Next, we would like to increase this variable count by 1 every time a new book object is created. Since the init method is the method function that will be called every time a book object is created, we may perform the counting logic inside this method. We do it as follows. Notice within the init method, there's a book.instanceCount is equals to book.instanceCount plus 1. Take a moment to look at how we structured the logic of our script. The whole concept of class side data is not difficult. We have done much more difficult topics in the previous topics. Looking at the previous slide, we are able to see that there is a class variable that is created by the name of instance count. This variable was initialized to a starting value of 0. Then we see that we are using this variable to count and store the number of book objects that have been created. Within the init method, we are increasing the value of the instance count variable by 1. Look carefully here. We are accessing the variable name differently. To access class variables, you need to use the class name dot notation and the appropriate variable that you wish to use. So logically speaking, the variable instance count is not a part of any individual object, book object in our case. This variable is a part of the class. The class has access to this variable. It belongs to the class because this variable was not created within a method. It was created within the class. We say that the variable is created within the scope of the class and not within the scope of any methods. So, according to what we have coded, every book object that is created will be counted, and this count will be stored in the class variable named instance count. So let us see if our script logic works. We should first create a few book objects as follows. So we have created 5 book objects in Python. Now, if our program logic was correct, the instance count class variable should have a value of 5. Let us print the value to the screen. Print book.instanceCount. Notice we access the required class variable using the class name and dot notation. Output will show as follows: 5. So our program logic is 100% correct. We are outputted with 5, which tells us that the instance count class variable is holding a value of 5, and this tells us that 5 book objects were created, which as we know is 100% correct. This tells us that the init method was executed 5 times, therefore output is as we expected. That concludes class side data. Class side behavior. It is possible to define behavior that is linked to the class rather than an individual object. This behavior is defined in what we call a class method. Class methods are written in a similar manner to instance methods, which we have defined all along. However, the core difference is that class methods are decorated with the @class method decorator. The class methods take a compulsory parameter, which is the actual class, instead of the individual instance. The decorator needs to appear before the actual definition creation of the method. For example, if we would like to implement a class method that counts the number of instances of a class, we would do so as follows. First, we begin with a simple book class template. Next, we will create a class variable to store the count of instances that have been created. Essentially, a class method is when we are required to create a complete separate function, because in logical terms, a decorator is a function that takes in another function as a parameter and will return another function as output. Let us view this logic in action. So first, we will make use of the @class method decorator. We need to include the @class method decorator before we actually define our class method. Notice we have used the @class method decorator. Next, we begin creating this method function which will implement the logic of adding 1 to the class variable named instance count. In the exact same way that we have a compulsory parameter for methods, which is the self parameter, we need to pass in a compulsory method to all class methods, which is the CLS parameter. Within class methods, we may utilize class variables and perform operations on them, but when we are using the class variable inside a class method, we need to use that variable by using the CLS keyword, followed by dot notation and the class variable name. So the next phase of creating a class method after using the @class method decorator is as follows. Notice we have used the def keyword to indicate the creation of a new method function. After the def keyword comes the name of the class method. Next comes a pair of parentheses. Within the parentheses, we need to pass in a compulsory parameter, the CLS parameter. Remember, a class method will require you to pass in a compulsory CLS parameter. An object or instance method will require you to pass in a compulsory self parameter. Just like how the self parameter refers to this specific object, the CLS parameter refers to this specific class. So in this particular class method, we would like to increase the count of instance count variable by 1. And remember, when using class variables, we need to use the CLS dot notation. We would do so as follows. Notice that our class method is now shaping up well. So we have created the logic that this method will implement. But now, the class method increment instance count will not work. Why? Because there is nothing to call this method. You see, the whole aim of this method is to keep a track or record of all book objects that are created in Python. But now, every time a book object is created, according to our code, only 3 parameters are required, and there are 3 instance variables that each object will have access to. So essentially, we are going to have to call the class method inside the class, inside the method in which the object creation is done. So we add one more line of code to the init method as follows. Notice, within the init method, there is one more line of code that has been added. We say book, the name of the class, followed by dot notation, and thereafter the name of the class method function we would like to call. In our case, it is increment instance count. So that concludes our coding. But now we need to confirm that this script logic works. Let us use the same book objects as before. And now we will check the instance count variable as follows. Print book.instanceCount, and output will show as follows: 5. Excellent. Our script logic is working well. Essentially, what is happening, each time we create a new book object, the init constructor method is executed. Therefore, the lines of code within are executed, and the first line of code inside the init method is the lines of code which says book.incrementInstanceCount. This book.incrementInstanceCount is a line of code which basically tells Python to go inside the book class and run the lines of code inside the incrementInstanceCount method function. And inside the incrementInstanceCount method, the line of code which says cls.instanceCount is equals to cls.instanceCount plus 1 is executed. So essentially, the class variable instanceCount, which is inside this class specified with the cls keyword, is going to have 1 added to it. After the lines of code within the incrementInstanceCount method finished executing, then the program control returns back inside the init method and continues onwards from the point at which control left. So essentially, the arguments passed to the parameters will be stored in the instance variables for each object that was created. I do hope that this makes sense. About class-side methods. It is good to know that majority, if not this entire tutorial, dealt with the advanced topics in Python. This portion of the tutorial will provide us with additional information about class methods in Python. So essentially, we have experience with class methods and instance methods in Python. There are times in Python when it may seem unclear as to what code should go into instance methods and what code should go into class methods, because after all, they are both defined within a class. Two very important points to be aware of are: number 1, instance methods define the behavior of the instance or object. Number 2, class methods define the behavior of the class. Class methods should only perform one of the following functions. Number 1, creation of an instance. This is arguably the most important role that a class method can have. This class method defines how we can use the class as a factory for objects, and within we are able to stash an entire load of setup and instantiation work. Number 2, answering queries about the class. This role is useful and can provide us with useful objects that are derived from class variables. A good example of this type of method would be one that returns the number of instances that have been created which belong to the specific class. Number 3, instance management. Taking on this role, class methods will actively control the number of instances that are created. For example, a class method that allows only a single instance of a class to be created is termed a singleton class method. Number 4, providing examples. There are some situations in which a class method is used to provide us with examples which explain the operation of a class. This is a good practice. Number 5, testing. Class methods may be used to support testing of an instance of a class. By testing, we mean that these class methods may be used to create new instances, use those instances and perform an operation on them, and compare the results with a known value. If the values do not equalize, then the class method can output an error or a warning message. Number 6, support. A class method which takes on a support role will mean that it will try to assist with performing on any of the class roles that we have mentioned thus far. Any other task or behavior that needs to be implemented should be implemented by an instance method.